All right, buckle up, space cadets. Today we're going on a grand tour, not of our local neighborhood, not Mars, not Jupiter. We're going interstellar. We're venturing out into the cosmic ocean to visit worlds that defy imagination. These are the exoplanets, planets orbiting other stars. The universe is a big place. It has more planets than stars. So you can bet it's cooked up some truly bizarre real estate. Forget what you see in science fiction. The reality is far stranger. It's more mind-bending than any Hollywood director could dream up. So grab your space helmet. Our journey starts now. Our ship is fueled by curiosity. Our destination? The frontier of human knowledge. We're hopping from one planetary system to another. Each stop reveals a world with its own brand of weirdness. Planets made of diamond. Worlds where it rains glass sideways. A planet older than we thought possible. These aren't just theoretical ideas. They are real places. We've found them. We've measured them. We've studied the light from their parent stars to unlock their secrets. This is science at its most thrilling. It's exploration for the 21st century. The universe is calling. Welcome to the Cancer constellation. We've arrived at the star system 55 Cancri. Our target is the innermost planet, 55 Cancri E. From a distance, it might not look like much. It's a super-Earth, about twice the size of our own planet. It orbits its star so closely that its year lasts only 18 hours. Imagine celebrating your birthday every single day. The proximity to its sun means one thing: heat. The day side of this planet sizzles at a temperature of around 2,400 degrees Celsius, or 4,400 Fahrenheit. That's hot enough to melt steel. But the heat is just the beginning of the story here. This planet is special because of what it's made of. Scientists think it's a carbon-rich world. The immense pressure and heat deep within its interior could do something amazing. It could squeeze that carbon into diamond. Yes, you heard me right. A planet with a thick layer of diamond. We're talking about a world where a third of its mass could be pure, glittering diamond. Forget diamond rings. This is a diamond planet. It's the ultimate cosmic treasure chest. A place that would make fortunes on Earth seem like pocket change. It's a geologist's dream and a nightmare all at once. This diamond world is not a friendly place. It's a world of extreme wealth and extreme danger. Now let's leave this cosmic jewel behind. Prepare your eyes for the darkness. We've traveled about 750 light-years to the Draco constellation. Our destination is a planet named TRES 2b. It orbits the star GSC 03549 02811. This planet is a hot Jupiter, a gas giant that orbits perilously close to its parent star. It's about the same size as Jupiter, but it reflects almost no light. It absorbs more than 99% of the light that hits it. To put that in perspective, fresh asphalt reflects about 4% of light. This planet is darker than coal, darker than black acrylic paint. Why is it so dark? One theory is that its atmosphere is filled with light-absorbing chemicals. Vaporized sodium, potassium, gaseous titanium oxide. These elements would act like a cosmic sponge soaking up the starlight. Whatever the cause, the effect is eerie. This world is a giant black ball hanging in space. It doesn't shine, it just absorbs. It's a gravitational ghost, but it does emit a faint, dull red glow. It's not shining, it's smoldering. Our next leap takes us relatively close to home, just 33 light-years away in the constellation Leo. We're visiting Gliese 436b. This planet is a Neptune-sized world orbiting a red dwarf star. It's another hot planet with a surface temperature of around 439 degrees Celsius, or 822 Fahrenheit. At that temperature, you'd expect any water to be steam, a thick, hot vapor. But here's where Gliese 436b gets really weird. Scientists believe this planet may be largely composed of water. Not liquid water, not steam, but a bizarre form of solid ice. How can you have ice at over 400 degrees Celsius? The key is pressure. Gliese 436b has immense gravity. This gravity is so powerful that it compresses the water molecules on the planet. It squeezes them together so tightly they can't escape as gas, even at scorching temperatures. This isn't the ice you find in your freezer, which is known as ice IH. This is a high-pressure exotic form of ice, perhaps something like Ice 7, Ice 10. We call this stuff hot ice. The planet is also losing its atmosphere. Set your coordinates for the constellation Vulpecula, about 63 light-years away. Our next stop is HD 189733b, a deep azure blue reminiscent of Earth. You might be tempted to call it an ocean world, but don't be fooled. It's a hot Jupiter, orbiting its star in just over 2 days. That beautiful blue color doesn't come from water, it comes from an atmosphere laced with silicate particles, tiny grains of sand, glass. The winds on HD 189733b are ferocious. They blow at speeds of up to 8,700 kilometers per hour. That's more than 7 times the speed of sound. It's a supersonic gale that whips around the entire planet. The heat from the star melts them into droplets of molten glass. The supersonic winds then catch these glass droplets and blast them sideways through the atmosphere. It literally rains glass, sideways at thousands of miles per hour. It's a perpetual global storm of flying glass shards. So while the planet might look like a tranquil blue marble from a distance, up close it's a death trap. We determined the planet's color using the Hubble Space Telescope. A cosmic lesson in not judging a book or a planet by its cover. Let's take a journey not just through space but through time. We are heading to the globular cluster M4 in the constellation Scorpius. It's a dense, ancient swarm of stars about 13 billion years old. Here, orbiting a very strange pair of stellar corpses, we find PSRB 1620-26b. This planet has a nickname, Methuselah. At an estimated age of 12.7 billion years, it is the oldest known exoplanet. It's more than twice as old as Earth. It formed when the universe was just a baby, only a billion years after the Big Bang. This planet's existence is a profound puzzle. In the early universe, the elements needed to form planets were extremely rare. Carbon, oxygen, silicon. The first stars had to live and die to forge these elements in their nuclear furnaces. So how could a gas giant, about 2.5 times the mass of Jupiter, form in such an element-poor environment? Methuselah tells us that planet formation started much earlier than we ever thought possible. Planets are not a recent innovation, they are an ancient feature of the cosmos. This planet has had a chaotic life. It has survived stellar evolution, stellar death. The discovery of Methuselah was a long process. This ancient world, a true cosmic survivor, forces us to rethink the timeline for life in the universe. If you thought one sun was enough, get ready for a triple feature. Our next stop is the star system HD 188753, located 151 light-years away in the constellation Cygnus. Here we find a planet, HD 188753 AB, that would have a truly spectacular sky. It's a gas giant, slightly more massive than Jupiter, and it orbits a star that is part of a triple star system. Imagine standing on one of its moons and looking up. You would see 3 suns in the sky, a main sun-like star, a more distant pair of smaller stars orbiting each other. The existence of this planet, sometimes called a Tatooine planet, challenges our models of planet formation. The gravitational environment in such a system is incredibly chaotic. The gravitational tug-of-war between the 3 stars should have made it very difficult for a large gas giant to form and maintain a stable orbit. Yet there it is, a cosmic impossibility that exists anyway. The planet orbits its primary star very closely, with a year that lasts only about 3.3 days. The view would be breathtaking. A large yellow-white sun dominating the sky, with 2 smaller, dimmer orange suns appearing as a close, brilliant pair in the distance. The shadows would be complex. The sunsets and sunrises a constantly shifting spectacle of light from 3 different sources. Our journey is over. We're back in our own familiar solar system, but we return changed. We've seen a planet of diamond. We've seen a world of darkness. We've witnessed burning ice. We've witnessed sideways storms of glass. We've visited an ancient world that predates our own by billions of years. We've seen a planet with 3 suns. We've seen a gas giant that would float in water. These worlds are not science fiction. They are real, out there, part of the grand cosmic tapestry. They have a profound story to tell about our place in the universe. But exoplanet discoveries shattered those categories. The universe is far more creative. They make our blue marble seem more precious. The exploration has just begun. Next-gen telescopes like James Webb give clearer views. They sniff atmospheres. They search for chemical fingerprints of life. The universe is a book with endless pages. We've only read the first chapter. Keep looking up. The cosmos is waiting. The journey never ends.